In this video, we will explore an exciting project that combines the power of OpenAI embeddings, the Laravel framework, and kind of like PDF searching. If you've ever struggled with finding specific information within, PDF documents, then this project is for you. I've developed a Laravel application that leverages OpenAI embeddings to convert like PDF files into searchable vectors, by using kind of like a natural language queries. So you can now easily search through PDF documents and retrieve relevant chunks of text based on the similarity scores. And these advanced searching capabilities made possible by utilizing um, what I've utilized in my case. It is cosine similarity, to ensure that the results are accurate and efficient. So throughout this video, I will take you through the step-by-step process of integrating the OpenAI embeddings, and performing searches on PDF documents. We'll also demonstrate how to combine the user input with PDF content to kind of create prompts for the OpenAI models. In this case, it would to be text Da Vinci, and enabling you to ask questions and receive answers based on the knowledge base. So this will become kind of like our knowledge base, which is extracted from the PDF, right? Um, yeah, without further ado, so let's dive in and discover um, the word of OpenAI embeddings. All right. So first of all, let me show you how this project works first. So this is what happens. So first, I kind of like upload a PDF file here. Let me see. Okay, let me use this one and then upload the file. Ooh, can I just do this? And then the file created and converted successfully. And then I have another link here, which then after uploading a PDF file, then we want to search through that PDF file. So in this case, you type the user input and then I select the file that I want to search, and the file that I uploaded recently, it is this one. I'm going to select it and then I'm going to ask some kind of like a question here to search through the PDF file. But so the PDF file that I've uploaded, it is this one. So let's ask a question here. Uh, so let's ask this question, like who founded the Adventist Church? Yeah, let's do it like that. Let me ask this question here. And as you can see, the church was founded by a group of Christians who were passionate about the Bible and its teaching. So let's ask that question. Um, who founded um, who founded the Adventist Church? And then we select the file which was recently uploaded, which is this the file that I recently uploaded, and then I can search through the file. And there you get the results. The Seventh-day Adventist Church was founded by a group of Christians in the mid 19th century. If we go back to the very same document here, you get the, which is this one. Um, as you can see, that the church was founded by a group of Christians who were passionate about the Bible, and this is what basically uh, you get as the um, is kind of like the answer. All right, so let's try and say something different again. So let's try um, something that has a date within it. Um, okay, when was the Adventist Church formed? As you can see, it was formed in 1960. So let's try and ask the same question. Um, so let me say, when was the? Okay, let me just do this. When was the Adventist Church? under search formed. Let's do this, and then I can just search through the file again. And there you see this. So the advantage was formed in 1860. Now, if you go back, let's go back and check actually. So as you can see, it was formed in 1860. Yeah, that's basically how this works. So before I go through the code, let me start off here with this chart. So this is what's happening here. So first, we upload a PDF document and then you convert the PDF file into some text. I tried both of these packages. They work fine. I tried this PDF parse and spatial package. Right, for me, they kind of like work fine in the spatial PDF to text to convert the PDF uh, to into some text. Right, so we can use this other um, package here, which I've used, uh, right, which then converts this PDF into some kind of text. And then what happens after that is that we do some pre-processing. This since the text is now been converted, then we pre-process it, especially if you wanna take this text and put it in through a kind of like a natural language. Then you might need to pre-process the text. So what I've done, tokenize the text and normalizing it, also steaming it. There are many ways to we can process the text, and there are a lot of packages out there that can be used to accomplish that. Uh, then after pre-processing the text, then we split the text into some kind of like chunks, right? And the reason why you'd want to do that is because remember, since we're using OpenAI, it has some kind of like token limits. So that is why but this is one of the reasons why you want to split the text into chunks, right? And then yeah, you split this text into chunks, and then after doing that, we convert these chunks into vectors using OpenAI text embedding model, and then we store these vectors uh, and chunks into the database. And then after doing that, now we have our own knowledge base, right? Then if we to ask questions, to we kind of get the user input, convert it into a vector, and then what happens with that, since we getting this input as a question, then we convert it into a vector, and then we search, to the database of vectors for relevant vectors. So in this case, I've used cosine similarities to search through the database for uh, similar vectors. And then after that, what happens after we retrieve the relevant um, vectors? We combine these. Um, we get the um, the relevant vectors as chunks. So after getting the similar vectors, we need the text of those kind of vectors, right? That is why then we get those relevant vectors as chunks, right? As the text, and we combine the relevant chunks into a single string that will make a knowledge base. Then we can then construct a prompt using the user input as the question, um, and then we also using the knowledge base, which is these text of chunks retrieved from the database. And then now using OpenAI text adventure model, we ask the model a question based on the prompt, and that's it. So yeah, let's go to the code. So let me start off with the migrations. Right, so here, this is what I've done. So first I have this migration file. In this case, this one is it's for PDF documents, which in this case it is a name in the file. This stores the file, PDF file along with its name, and then another table again or other migration file for text. Right, so this what happens is that we get the text, right? and which is also we have also a foreign key for the file ID, right? So we so what happens is that when the PDF gets converted, rather we extract the text from the PDF, or rather the PDF is converted to some text, and what happens that we split, right, the text into chunks. So those chunks we store them in this file, also specifying the 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 file ID for that particular text, right? So this migration file store all the text as chunks, but also we want to also know whether the text itself is from which file, right? And then what happens also is that I also have this migration file here, which then stores the vector, and that I've made this uh, field a JSON, because remember when we use the OpenAI text embedding a model, it returns um, kind of like an array of some numbers. So that is why I made this field a JSON, so that we store the vector, right? And then here the text ID, right? Remember, we take we after splitting the text into chunks, we take each and every chunk, then we create a vector for each and every chunk, right? And we store it in the vector itself in this database. So we store the vector. We also store the text ID. This is important for you for the text ID. Although there's a different migration file for text, right? So I've separated a table for text and then another table for vectors. But in this case, the text vectors, the table that migration file that stores the vectors itself has a foreign key of the text, so that when we store a vector, right, in the database, also storing its its text, so that we can easily retrieve the text based on the vector. All right, and you also store the file ID. The reason why I store the file ID is because in this text vectors table, it stores all the vectors from each and every file that is uploaded. So at some point you don't want to you only want to query rather to search through a certain file, rather some text for a certain file. You don't want to search through all the vectors which are kind of like irrelevant to that file. So that is why when you search through the the vector database, we select a file so that we only search the relevant vectors, not something or text or vectors from text that is kind of like not relevant to what we want to search in that file, right? So, yeah, that is why I've done that. And then I have this other, um, anyway, this migration is not necessarily important for now. And then, yeah, that's it. And then, so I'm actually a Livewire fan. So I've used Livewire. I mean, like Livewire, I tend to use Livewire, yeah, depending on what I'm doing, as full page components. And I've used Bootstrap, right? I also use Bootstrap because of its simplicity. And as I said, I've used Livewire. I mean, it works better for me, right? So, um, and then I've created two components, Livewire components. And the first component which I've created, although the naming of these components may not be relevant because Uh, this this is not what basically I was intending to do with this project when I was naming these components. But anyway, if it works, it works. And then yeah, so this component here is the one where we here where we upload a PDF file. Um, so upload a PDF file here. So this is the component. So what I've done here, of course, validation, right? Since this is live wire, yeah, um, yeah, because I'm uploading, I'm using with file uploads, otherwise it would not work. And then validating the PDF document, and then yeah, I have this function get file, and then validating, and then here what happens that we getting the file, storing the file, and then what I'm doing here is that I'm creating the file, right? Which I'm creating the file name here, and also storing the file. Um, and then now, in this case, what happens next is converting the PDF to text, right? I've used this package PDF uh, parser to convert this PDF file into some kind of like text, right? And then after doing that, I kind of like pre-process the text. First, I'm tokenizing the text. There are a lot of packages that can be used to accomplish that anyway. So yeah, I've tokenize the text here, and then here normalize it, and then removing stop words. All right. These may not be necessary, but depending on what you want to do, at some point you may want to remove stop words. And then stemming the text itself, right? And then after doing that, then we split the text into chunks, right? And then the reason I'm having overlap words is so that I don't just cut the text within a sentence. You want the text to have some kind of like context. That is why I'm using some overlaps there so that the text can have context even though it's cut, or rather it's being splitted. Um, yeah. Otherwise, yeah, that's what basically is happening here, right? And then, and by the way, this is valuable. This project is valuable on GitHub, so I'll provide the link in the description below. Right, and then now for each and every chunk, right, after pre-processing the text, now for each and every chunk, we using this package by I think it's Nuno Maduro, a very great um, package, OpenAI Laravel package. This is what I'm using, and then I'm using the embeddings, and then the model is text embedding, and then for each and every chunk, right, that has been pre-processed, we we convert it into a vector, right? And then what happens is that I first store the chunk into the database, right? For each and every chunk that has been pre-processed, we store it into the database. We have a migration file there for text data, which stores only the text from the PDF file, right? And then we also store the vector, right, that is being retained from this open AI here, using the text embedding, so ADA. So what happens is that we store, I first initially I create um, kind of like we store the chunk, right? We store each chunk, and then we also since we have kind of like a foreign key inside this text vector to reference the text for each and every vector that is stored right in this vector database. So first we create the text, and then using the text ID, we reference it here as the text ID inside the vector database. So we store the vector, right? I'm using JSON encode here because remember that is an array there that gets retained by this OpenAI. Um, and then what we do, we store it to a database. We also store the text, which is um, referencing this um, embedding, right? And then we also store the file, right? The file ID of this, so that it is easy for us to search relevant text from the file, not to search the um, entire table, right? And then yeah, that's basically what's happening. And then after doing that, we this file has been kind of like it's being uploaded. Then if we go back to this page here, which is there, another kind of like another link again, where what happens that the user now can ask a question and then select the file, right? And so here here's the class. So here's what happens here. So first, of course, I do some validation here. The document that the user to select, and then the input, the user input. And then I first we get this kind of like since the user select kind of like a document here. So once the user select that document, we want to find this document, right? And after finding that document, what we do here, we convert the text, the user input rather, into a vector using the OpenAI text embedding. And then now what happens that I have created a kind of like a class, even though I was struggling where I would place this class, but I've just created a kind of like a directory, and then I've named it services, and then inside here I've created this class which does most of the work. So this class here has some kind of like functions. This one function get vector for text, to retrieve text based on, or to retrieve vector based on the text. And the function here which these gets text IDs. Um, and then another function again, which this one just gets text from a vector that's being passed. And then yeah, this is the function then which does some kind of like using cosine similarity, which kind of like retains relevant vectors, right? Which is the same function that is being used here. So now I've kind of like using this class I've created, and right we instantiate the class, then using this get most similar vectors function, which then accepts kind of like three parameters. The first one here, it's rather arguments. It is we get the vector. Remember, first what we do, we get the user input, right? We convert it into a vector, and then we search using this vector user input, which has been converted to a vector. We search through the database for relevant vectors to these vectors, right? Right, to this vector. And then we also pass in the PDF file along with the limit. Right. The reason why me having the limits, it's because remember, as I've said initially, that OpenAI has some limits, right? Token limits. So you don't want to return too much text because you might you don't want, although you can actually specify the max tokens here, but I think it's best if you can specify the uh, limit in terms of kind of like similar to tokens that can be retained, or rather text that can be retained, because if it's too much you might actually get an error here while you when you pass it here as your prompt. All right, so if I go back to this class, yeah, this is a class that's actually, it accepts an array of kind of like a vector, right? And then the file ID, which we would want to, um, rather, we want to get vectors from a certain file that the user selected. And we don't want to search through the entire vector table. No, we want to search a certain file. So that is why it's, or a reason why I pass in the file ID here. So we get the file, right? And then mapping here, and then return the what? The vector ID, yeah. And then yeah, this function actually does it, right? Does some similarity, you know, search and retain some relevant vectors. Also, it's some kind of like based on the similarity score, and then yeah, it retains some relevant vectors. Uh, yeah, and then what happens is that, although actually there are many ways to do this, right? There are packages that can be used that you can use to do some, calculate some, cosine similarity, or rather even other methods that can be used to accomplish to say the same thing to search through some kind of like vectors. All right. Then after doing that, this retains some relevant vectors, right? And then what happens is that again, using a function again from the vector service class, get text from IDs. So this is the function here. Um, since that this returns relevant vectors, and it also returns IDs of those vectors. Then we get those IDs and try use rather use those IDs to get the relevant text of those vectors. So that is what this function actually does, right? From these uh, vectors that have been relevant vectors that have been retrieved, we want to get the IDs of those um, vectors, right? And then search for the text from the text table, right? And then yeah, and then from there we have our own kind of like knowledge base, and then we can create our prompt here, right? Although there are many ways to make this prompt kind of like better. What I've just done, I've just said, you're an expert in answering questions. Please answer the following question, and then I pass in the question, which is the user input, and then using only, I've told, or rather in a prompt to specify that I want these to use only the source documents which I've provided, which is our knowledge base, which is these chunks that have been retrieved um, from the database. And if the answer is not there, rather could probably have made this better. If they don't know the answer, they could say, sorry, I do not know. We could try that and search. Yeah, we'll do it anyway. So yeah, and then that's it. And then after doing that, then we take, now we have our knowledge base, which is combined to the user input. And then now we can take that, we ask the model based on the on the prompt. So I'm using text to in this case, passing the prompt and then the number of tokens that can be retrieved, and then yeah, that can be returned rather, and then yeah, you get the answer. You're taking the answer and storing it here, or taking the answer, storing it in this variable answer that I've kind of like declared. Yeah, and for instance, let's try it once more. Let's try another kind of like document. To that to make sure. Um, so let me upload a document, and then let me use this one about essay history, and then I'll upload it. Yeah, and then we can come here and say um, and then let's select this document which was recently uploaded. Then let's ask. So this is the document. Let's see what we can ask. So let's ask this the truth. Let's ask this question here. I'm just gonna copy this. Come in and just say um, when was the Truth and Reconciliation Commission established? And then let me just search. Okay, the Truth and Reconciliation Commission was established in 1995. As you can see here, uh, it is, oh sorry, it is formed in 1995. So let's try and ask one more question. Um, okay, let me do this. Copy this here. Um, mm, let's search. Okay, as you can see.